see if I can hear things. Yes, I can. Wow. Ooh, my hearing is awful today. Oh, well, got a cup of coffee. Yeah, we've got a stream. Welcome to day 21 of the C++ programming club, as we are deep into 3D. 3D. And fresh coffee. Should always start with the fresh coffee. Alright, where were we up to? If I click a button, we should find out. Oh god, yes. Renderer. I remember this. Didn't I do something very similar to this last November? I wonder. I think the answer is yes, we did. We've got our MVP stuff here. We don't have our camera and we don't have our light. So we're going to skipping the V. We've got the M and the P. But we do need a batch renderer before I do the camera and light, because this is all tied together, this little corner here. So create shader we've got, base shader. Well, let's start with a base shader. Then we'll make colour and texture out of that. We can use inheritance. And then we can do the draw functions using those shaders, or the correct shader. And then we can have a batch renderer that will call these in sequence. Yeah. I think that's what I made, isn't it? Let's have a look. Where are we here? Ooh, no. Here. What have I got here? What's this one? Yeah, this is okay. So last November I started a playlist, stage 1, and went through stage 2, stage 3, and everything there. And that has the renderer in it. What I'm going to do is I'm going to use the same renderer, the plan for the renderer, and I'm going to rewrite it into something that we can use. I think that's fair enough. In the code side, there was something I wanted to look up. I'll show you what I want to look up. On the code side, as you can see, the code has vanished. We've still got shaders, we've still got the model warehouse, but now we just have initialized models, and voila, we have models. Model warehouse is going to take everything, and as you can see, model warehouse update all fires the renderer, the master. We'll have to put master there now, because we're going to have a master renderer. Yeah, a master drawer. No, it doesn't sound as good. Master renderer will have to do. Everything's gone over to Amber 3D. So in Amber 3D we have added to the core a model warehouse, because that's the core stuff. And in OBJ data we now have a store OBJ data. Yay! And it's this that I'm concerned about. I had to add some -1s, as you can see down this row here. I then added them to the texture coordinates, which is correct, and I got to this point here and thought to myself, should I be adding -1s to m underscore current color? And I couldn't decide, so I put them in. Have I got a converter anywhere that I can look at? Should have. It'll be under some kind of API thingy. See if I've got an API here. I have. It's got a data loader. Models, model base, yeah. Load to VAO, yeah. We've done all that. Let's have a look. Mass. No. Model loaders. OBJ loader. Let's have a look in here. See if I've got a converter. Here we go, I've got a converter. So it's -1s all the way down. What about colour? I've got textures, but no colour. Because I never did the colour. Now that's interesting. I've never done that before. Oh. Fine. So the answer is not sure about those -1s. It's better to have them as -1s because that's obvious if it creates an error. If no error is there, then we've got it right. If it does create an error, we'll spot it a mile away because there'll be segmentation errors and like -1 colours knocking around which just don't exist. And it's going to mess everything up, which is good. That's what we want. Right. Rendering a render engine. Render. Yeah, one of them. API. No, it's OpenGL. I want for this. This comes onto my OpenGL work. Here we go. Here we go. Right, yeah. It's under my OpenGL work. So this is what I've done. All I've done is like taken, literally, cut and paste, as you can see. Struct object data. Put all the correct includes in. Wait a minute, just put it on the screen again. There we go. Correct. I've put all the correct includes on. I'll keep that there for a second whilst I grab my coffee. So that you can pause if you need to. For reference only, it's stayed. I'm going to keep it. Struct for the model is there. Yeah, we've got the model matrix in now, haven't we? Wow. That's virtually done. That is done, I think. Or as close to as done as can be. -1 is an error, by the way, for a model. If a model has a UID of -1, it's an error. Model gets destroyed type of thing. Store object. We've got all of those lovely vectors for messing around with the data. And it just boils down to two confusing ones here. We have data to OpenGL and data to GFX. Well, that's convert data to OpenGL format. So should we put format after that? It produces a model though. That's the only thing that actually produces a model. That's interesting. I wonder what we did with it. Yeah, store the faces, create the VAO. It's all in here. So the CPP is just the same as it was before. So data storage. This is what we wrote in our development. I'll try and go through a bit slower in case anybody needs it. Just to look at. There we go. So clean storage, return current model loading, wherever that's returned to. Probably here. Load texture now. That just loads a texture. I'm still thinking we might put some more stuff in there. Create VAO, yeah, that's good. Binding, storing, creating, storing. Yeah, it's all there. I think that's the best version of store face I've ever done. In C++. In Qt, I've got a better one than that. I think I have, but it's about the same number of lines. So that's the store object that we have made. We have also made, that's the core. We have obviously, oh no, that's what I've just been through, isn't it? So up jump core data, we now have our model warehouse, which looks like that. Yeah. So initialize models, update all, and we've got a load model as well. And it's a load model that kick-starts the OBJ loader, which we have. You can look at that quite easily. There's nothing much here. So initialize models is load model Bob. Why, we haven't exactly stored it very far, have we? Oh yes, we have. We've stored it here. Yeah, so there you go. Data to OpenGL returns a model, which we put back onto the tech level 3 shelf. We're going to use this tech level 3 shelf to send our models through to on the update all when we render. As he says, render here. Yeah, it all works. All works. So let's just run our test program and see what we get. Won't surprise you what we get. So test program, let's run it. And this is where we're up to. Yep, it's now nearly done. Come on, you can do it, you can do it. Yay. There we go, there's our bash. And that's how quick it is, yeah. It's already loaded the model and it's all already rendering. But we haven't got the renderer yet. So you can see it's rendering. I've closed that. The data storage is destroyed, the warehouse shuts down, and you press any key to continue. So all we need to put into anything that wants to use this system, well, that's gonna be moved today. So this isn't needed here. All we're going to do is literally kickstart the model warehouse and then ask it to render. Wow. The model warehouse is going to control, it's going to have shelf after shelf of models that we need, and the renderer is just going to render the correct models. And that's the interesting part. How do you find out what the correct models are? I've had thoughts about that. So today, without further ado, let's start coding. And I'm going to have namespace, Amber 3D, because that's what we're going to be, that's where we're going to put it at the end of the day. We can start that up. What's wrong with the namespace? Oh, I don't know. And class. So let's have. Is it? I don't know what's going on here. Go on, I'll pop you up one line just to make you look good. For some reason it can't get hold of my namespaces. Is not allowed. Yes it is. No it's not. I'm in the wrong place. Good point. Cut. I put this in the wrong place now, haven't I? Here we go. We're in prototype 1. Sorry, my bad. My bad. Let's do a prototype of our shaders. So as I said, we're going to need a foundation, something to inherit from, so that all our shaders do the same thing or have the same base operations in them. This is important because it means that all your shaders will work the same. in theory. In practice, that's not quite how it works, but it's a good theory. C++ lends that to us in form of inheritance. So today we're going to look at inheritance. Yeah, I haven't done any inheritance, and there's some people entering the stream, so welcome to all. I'll show you what we're doing now. So welcome to all. We are going to be doing our renderer, batch renderer. We're going to start down here, follow up here, and go into batch rendering. So we're creating the shaders stuff here now. Mostly because I want to get that up here. So let's have a look and see what we can do. I think we can do a class for this. Well, we have to because it's inheritance. We'll call it shader foundation, as it's going to be the foundation for each shader. And that should do us for a class. And then it's just what do we want to put in these classes. Don't know yet, so we'll go to public. And we'll also have private, just in case we need it. Might do, don't know yet. Oh, we're going to need a special one, aren't we? This is inheritance now. Protected, that's what it's called. Protected. What that means is it's like a public function, but it can only be used by whoever inherits shader foundation. So it gives functionality through inheritance, but it's protected from the public, as it were. But it means I can also use bits and pieces in there which are going to be nice. Okay, class. How many shaders have we got? I want to make a constant. I'll make it static. I'll make it const. I'll make it a uint. Yeah, I'm doing good here. And we're going to call it in caps num. It's like a hash define. Actually, I could just use a hash define, couldn't I? I can. And that would be better. Because we can put that here. Hash define. And it's going to be num underscore shaders. And we're just going to have 2. Okay. Because that's all we've got. It's not 3 yet. It will be 3 soon, but not yet. What else can we have? I'm going to need a program ID of some kind. Because shaders are programs. For now, I'm just going to put uint. I don't know how this is going to work. Uint m underscore program ID. I've just got a theory that I might need one, so I'm going to put one in. Might not. We might take that out. Or we might need a vector of them. I don't know yet. Should only need one. So that's it. That's all we're dealing with. This is the foundation, remember. Not the actual shader. This is its foundation. So here we can have shader foundation, obviously. And we'll have one of those. This is going to have to be virtual. I'm just wondering whether I should make it explicit on the shader foundation. I think I should. I'm going to try anyway. If it doesn't work, it doesn't work. Shader foundation. I'm going to try and make this explicit. And see if that will work, because if it does, it's better. It means you can't use it any other way. what happens is the explicit word, I better tell you what it does. When you compile, your compiler will try to optimize your code. So if you don't put explicit there, it means it can optimize it. If you put explicit there, you're telling the compiler to say, no, don't optimize this. This is how I want it. This is how I want it to be used. And nobody can use this any other way. And that's what explicit does. It stops your compiler messing it up. So if you ever wondered why people put explicit before their constructors, that's the reason why. They don't want the compiler to touch it, and they want everybody to use it as it is. Instead, it also stops people just making something like, what would it be? You wouldn't be able to, no, I'll show you, it'll be an error, because you won't be able to do it. Let's put a const std string in here, for instance, and we'll call it and file name. Okay, so if I put that in there, I now cannot, under any circumstances, type in amber 3D : and it's shader foundation. So shader foundation. I cannot now put in s, a variable name, and just do that. I can't do it. It won't let me. I can't do that. Well, I can, but it won't work, because that will call the default constructor, and the default constructor is shader foundation const. Actually, should make that default as well. So default. There you go. That'll stop the little bugger doing it. But I can't. No, I can make it explicit. I don't think default's a good idea. Okay. But it stops people from doing that. And it's allowing it at the moment, but it will work out for itself that that isn't allowed. You would have to put a string in there. That is allowed. You can see it's now turned a different colour. But the default constructor will be compiled out, and hopefully that will become the default. I'm hoping it does. It might not. Hey-ho. Hoping that works as well. But explicit stops your compiler from messing it up. That's a big, big, big thing. Okay, what shall we put in here? What Muppet? Thank you, Muppet. Okay. This is where our shader stuff goes. So here, oh, the cat's off on one. We are going to put m_program ID, and it's equals compile shader and then we just need the file name, don't we? File name. There you go. That'll work. So we've got a shader. Is that correct? Yep, looks good to me. Anything else I want to put in here? Nope. Not really. Oh, yes. That'll do. So that's your constructor. your destructor is going to be shut down shaders, which has to go down to 1 now. You can't have both. So I'll just copy that. We're going to need another thing here. And what we're going to call it is, for now, void stop, just for a second or two whilst I work out what's going to go in there. But what we have to do is we have to make sure that the shader has stopped. So we stop. Then we put in whatever we had for shutdown shader, and it comes in as mprogram_id. So we need to alter shutdown shader. Okay. Program ID. Now that's incorrect. We need to go to our shaders and have a look at what we did there. And make sure that we can shut down a shader. I mean, it's very easy to do, but it can be icky. Core compile shader is that. Yeah, it's not even a class. Load shader isn't. Create shader, compile shader, shutdown shader, yeah. Is just going to be that. And it's a uint. Yes, that's good. So we're just going to do that. That's all we're going to do. Make sure everything's okay there. Amber 3D, compile. Thank you. We're okay. We're okay. So that's okay now. It doesn't like it still, but it's okay. And that does the shaders. Yeah. That does that bit. So we can get rid of all of this shader stuff. And I think we can get rid of that line there as well. Good. So all of that has just been replaced by create, delete. Program ID is a uint, isn't it? Yes, yes, that's okay. Too few arguments. Yeah, I know you don't know yet. You haven't worked it out. So what do we do in stop? Well, we better stop it. We could also do with a start, couldn't we? So let's have a start as well. I think they're just going to be voids. Think about it. Think about it. Yeah, we'll leave them as voids. Voids start. I'm actually going to put shader on it because it makes more sense. Otherwise, when you read the command, it won't look right. Right, let's make this one first. It's very... Oh, right, we're going to need something in here. Oh, how's my coffee doing? How are the people doing? Are you alright up there? Ah! Oroxa... What is this IDE? Ah, it's not an IDE. Oroxa, not sure if I missed your answer or did you not answer? Oh no, you didn't miss my answer. Sorry, it's me. I'm dead slow on picking up that things are coming in. My apologies. Shout out to you, mate. What is this IDE? It isn't. It's a text editor. It's a text editor offered by Microsoft. It's called Code, C-O-D-E, and you can download it. It's for any system. Let's show you. Just go back to a start page. If you just type in MS Code, Visual Studio Code, blah 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 blah. There's a Wikipedia. Code editing redefined. Oh, the jokers. No, it's not. There you go. Visual Studio Code. You can download it. Works on Linux. Well, it works on anything. It's an editor. It's just a text editor with programs that run on the left-hand side to help you out. So it's a programmable text editor. I think they're trying to compete with Atom, if I'm right. Oh, code blocks. Yes, I'll show you the conversion from code blocks to this. What operating system? Code blocks runs on any operating system as well. I actually experimented with that. I use val grinding code blocks to find leaks, memory leaks. That's what I use it for. Win 7. No, that's alright, it's Windows. Have I got a Windows setup here? Should have. First of all, under Windows, you would need dependencies. That's for certain. This is Linux, so I can just put SDL2 in. So you would need dependencies for anything that you were going to use. I've got GLFW. What dependencies have I got? I use Qt, Qmake. Oh, right, yeah. It's not just nice, it's brilliant. Try it out. The tutorials on the web page are close to being right, but not quite correct. They probably won't work. Just use a bit of hit and miss, and you'll get it, I think. You sound as though you know what you're doing. So if you do have problems, though, ask away. I've got this on Windows, I've got this on Linux. I can't help out on Macs yet, because I don't have a Mac. And that's why I still have a donate button. Yes, I know, it's bad. It's bad. I can't afford a Mac yet. The £800 that I saved up that was going towards the Mac has just been stolen by the boss. The boss said, no, I can't have it. So I've got to start again. Oh, excellent. Well, as long as you're having fun, stick with this channel. That's that's exactly what we're about. It's a club. It's all about you, the club members. In the background, yeah, I'm building this MMO. We all know it's impossible to build an MMO by yourself, but we're now into 3D. We're looking at 3D and stuff. So if you've got anything to add, or if you want anything shown, ask away. I'll do that. I mean, people have come along and said, "Oh, you should be using like what was it, threads and stuff like that." Well, I won't be doing. I'm just keeping it simple. So everything on here is simple, as you can tell by the way I'm doing this. It's the first time I've used inheritance, and we've got over 5,000 lines of code already. So yeah, exactly. That's how simple it all is. Okay, come on, you haven't caught up with me. Oh, why still OpenGL? Because it's simpler to use than Vulkan. Vulkan is still young. I would like Vulkan to go through about another 5 years of development yet before I start using it. There's going to be a lot of problems with Vulkan. OpenGL is still cross-platform. It'll still do anything I want. So I'm happy. I use OpenGL 3.3. I don't know if Vulkan would support that kind of thing, because I want this to be able to run on machines in Russia, where they don't have Vulkan. They have machines that can barely run 3.3. So this will all work on virtually any machine under the sun that's been bought since about 2000 anyway. So yeah, it's one of those things I'd want it to be able to run on a virtual end machine. At the moment, we're using a whole 15K to do the 3D. Our 3Ds at the moment up to 15K. So that's the kind of memory that I'm after. There's 50K of heap memory allocated to this, but 50K is still low. We're still doing good and we're loading models already. So yeah, I'm happy. No problems with that at all. Let's start a shader before that really starts annoying me. But yeah, don't be afraid to chat about anything. Please distract me as well. Yeah, it is. Aroxia just said he switched to Vulkan. Fantastic. Good on you. Stick with it. It'll go somewhere, I hope. I'm just hoping that the card manufacturers don't rebel against it like they did the last lot. And like DirectX, they were really rebellious against DirectX until DirectX went to Microsoft. And then DirectX became a thing. Because Microsoft said, excuse me, Mr. GPU users, GPU manufacturers, you now support DirectX. And all the GPU manufacturers said, yes, of course we do, Microsoft. Bow, bow, grovel, grovel, bow, bow, give us money. So Microsoft did give them money. And that's how DirectX was born properly. Yes, it does. Vulkan is a derivative of DirectX. Because Vulkan is a derivative of Microsoft's intention of taking over OpenGL. Because they can't. OpenGL is open source. Freebies. Vulkan may have a license eventually. Be careful. That's why I'm waiting. I want to see the license. End user license agreement. If it's got a license on it, ain't gonna touch it with a barge pole. Yeah, that's life. Oh, I've got a held message. Allow. I don't care. What did you say? Just to stop a shader from running. So this is going to be in an inherited functionality. So each shader is going to have the function to create itself, to destroy itself, to start itself, and to stop itself. So this will start the program running, and this will stop the program running. So it's an easy one, really, because to start it, it's just GL use program, isn't it? Yeah, I think so. GL use program. Yeah, that'll do. And it's just going to ask us for the program. So we're just going to put in M program ID. That's what it does. There you go. And to stop a shader is even stupider. It's a GL use program. And you just put a fat 0 in there. And that stops your program. So you can now start and stop your program. And this, by the way, is going to be inherited into the full shader. So you're going to have your program ID and everything created automatically. You'll be able to start and stop it whenever you want. And it'll destroy itself automatically. That shutdown I don't like. Yes, I do. Did I strip the shader? I think I did, yeah. I'll strip the shader down, yeah. It's funny you should say that. Will these take performance hits? No, because these will be compiler optimized. Whereas I had to put explicit there to stop the compiler from optimizing it. These will definitely get compiler optimized. There's no performance. No. You'll create the same code as inline. Don't need to worry about it. Compilers are very good these days. You do something like that, the compiler says, oh yes, rubs its hands together and optimizes it quickly. It loves one-liners, does our compiler. But they should do these days. I mean, you know, it's one of those things. A lot of things that happen in the background, people just don't realise. The optimization that takes place, God help us. I don't actually know what I'm using on here. No, I think I'm using Clang on here. I don't know what I'm using. I think I'm using Clang. Good point. No idea. What are you using, VS Code? It'll be that one, I think. So build. We're problem matching to GCC. Build GDB. Properties. Compiler path. Clang I'm using. Don't know why. Isn't that Mac? Anyway. It's on Linux, so I'm using it. It's a very good compiler. Clang. I think it is the Mac operating system compiler. Interestingly. I don't use Minghui unless I have to. It's a free open source compiler that in the past has had problems because it is open source. So I tend towards going for something that I know is more stable, and Linux offers Clang, so I use Clang. I just tend to choose what I think will do the best, on the platform that I'm on. On Windows, funnily enough, I probably will use MinGW64. Yeah, probably. As the compiler. So all you do is, obviously in your properties here, you just change it over to wherever you put MinGW64. How do you parse messages on your OBJ? Ah, right. Yep. Good question. How do I parse? I parse in a very simplistic way. What I do is I have this. It's called split. And what it does is it splits a string or a line of text into the component, well, splits by the search character, in this case spaces, because I'm using OBJs. So we're going to be using spaces. This will split and it alters and it stores everything in here. As you can see, it's coming in by reference. Alright, so that's what you're looking for. In the code, I will have one file that does it, and this is it. The splitting happens at the top here. So you parse a line of text. The first thing you want to do is get your split store ready, and line of text 0 equals, yeah, that's right. That's because the space gets taken off during the split, and I need that space for the V, whichever one it is. That one there, V, I need that space there. So that's what that adjusts. But all you do is you split your line of text, you send a line of text into here, you split it, and then you check every single different outcome. And it's not there, it'll be in the header. The different outcomes are them. All of these are different outcomes. So you can check for every single one of those. As you can tell, I've only picked a few. So you just check for what they are. Yeah, it's very simplistic because your split does the work, which is only a very, very, very small program here. That's your split. That's all it does to split. So I'll keep that on screen in case anybody wants to nick it. You can have that, it's free of charge. In your store, you are literally pushing these back into vectors. So all you do is you check what they are, push them back into a vector. The only one that's going to give you problems is the face, because the face has all of the indices for your vertex, then it goes on to your texture coordinates, and then it goes on to the normal index. So the face has to be done separate, so we have a store face option, that's right at the bottom in the private section here. So when we come to store a face, store object data, object data, store face. There you go. That's how you store a face. So you have to get the vertex texture and normal index out of it. And again, you can split it again by the slash. So you split it by the slash. It's always there, and then you just save it out, or, you know, chuck it into something. I push back into face elements, which I've constructed there. At this point, yes, I am going to miss weights and animations totally, because this is the prototype. So this is prototype 1. At this point, there's no way. All I'm going to go for is, let's see, where do I send it off? There we go. All I'm going to go for is the number of indices, the positions, the color, the texture, and the normals. So we have 2 shaders. One is color, one is the texture shader, which is what I'm writing at the moment. And those are the only things I'm actually taking, because that's your base model. Anything else after that I call a bonus. So you can evolve this to do as much as you want. It's easy. All you do is you go back to here, you add your check. At this line, you just add another check. Well, that line above the MTL parser or below the MTL parser. And, you know, just add it in. And you just literally add it through your program. Through all of the, you just follow your program through and it'll go in a direct line and you'll be able to add it through quite easily. It makes it actually quite simple to do, to add stuff. So the whole thing is expandable. And I've made it all expandable on purpose because it's going to expand. Oh dear, what should we have next? We'll need some other stuff here. We can't just stop a shader. Should start and stop a shader. Let's do some other stuff with this shader. I'm going to need some protected stuff as well, aren't I? Heck. Let's dream up a few things that a shader can do. This is the foundation, isn't it? So we've got start and stop. Right, I am, yikes, going to do this. I am actually going to do this, aren't I? Yes, I am. Right, let me just do a few protected ones first of all, so I get them out of my head. Because I know which ones they are. This one is a virtual void. In other words, it doesn't do anything. Virtual void, it's a placeholder. And all this placeholder is to bind the attributes. So that's that. Okay, because we want to bind all of the attributes within our shader. And we know where they are. They're at layout 0, 1, and 2. So we know where our attributes are from past videos. The models are .blend. Nope, models are .obj. They're here. There you go. Bob. We've got Bob. That's our test prototype model. All I did was go to Blender, dropped Suzanne in it, gave it the colour golden, and saved it and exported it out as a .obj, turning off textures. And that's our obj file. I'm not going to click on it because it asks me if I want to do some stupid stuff, and I don't. So, done that one. That's an easy one. I like that one. Actually, I can cheese that, can't I? Really? Because it doesn't do anything. Next one. I'm going to have a void. This is going to look really stupid. I'm now going to have bind attribute singular. Yeah. And that's going to take a uint. And it's going to take the attribute. And it's also going to take something else. Yeah, we'll better put it in there. Const char star. Don't like me star being there, sorry. Variable name. That'll do. Yeah, that'll do. Sort you out in a minute. Lovely. So we are going to need some other stuff here. Models, yes, it's got to be triangulated. We're using OpenGL draw elements. You cannot use quads. It forbids it. If you look up OpenGL elements, it states specifically that you must use triangles. In fact, I've got an error to report quads and just ask you to reformat it. I've put that error into the building, the reader, the parser. So I've added that as an error check. I think I put another error check in for something else as well. Right now I can't remember what it is. Possibly no texture or no colour. Probably something like that. Oh no, normals. I put one in for normals because you've got to have normals to have lighting, and both my shaders have lighting, so got to have normals as well. So make sure you tick that. And I've got a small bottle of black bubbly burpy liquid. Oh, it's gorgeous. Lots of sugar. Alright, I'm just going to list these out. Load. They're all loads. So we're going to load floats. We are going to be able to load. I'll just put that there. Void load vector. So we'll need to load those up to where, in case we need those. Space, do that. I'll keep it happy. Why have I got one down at the bottom that's not happy? Oh, it's in main. Main doesn't count. Right. Load vector. We'll have booleans as well. I might actually use that. Although it's not a feature of OpenGL in truth, but it is available. So we can. And a matrix. So void load matrix. What I mean by load is load or pin the values to the correct place in the shader. Load them up to the shader. Load to shader, a float, a vector, a boolean, and in this case a matrix. So we'll have those abilities as well. Space, blob. Right, so that's you. We'll do you in a bit. Private. I can't think of anything. Oh well, never mind. So we won't do it. We might need the program ID. In fact, we will need the program ID for the renderer. Yeah, the renderer's going to need it. So here we're just going to... Actually, no, I'll do it at the end. I'll do it in the proper place. We'll do a getter. I never do getters and setters. But we're going to do a getter. Wow, a first. No, I think it's the second one I've done in the whole programming. I don't like them. Getters and setters just mean bad programming. And with inheritance, it's bad programming. So yeah, we'll have it. Get program ID. So we'll have that. That's just return. Yeah. M_program ID. There you go. That's done. Right, let's have a look at these. You'll like these. These are funny. Remember, this is not the actual shader, or the shader program. This is the foundation. This is going to give functionality to the shader program. So, these, again, you can expand, because you might notice I don't have int. So there are things here. And vector, I mean vector. Oh. Ah. We have too many different types of vectors, don't we? That's a problem. We'll have to solve that. Right, let's write these first and then we can solve it. Well, when we need to anyway. We'll solve things as we need, but we'll get the basics in first, because this is only a prototype, so it's perfectly okay. To load a float up, you need to know its int location, in the words 0, 1, 2, or whatever, in the layout. That's the layout's location. Okay, and you also need to know the float, I guess. And we'll just take the value. So nothing special going on there. Excellent. You might see now some similarities going on. Oh, right, yeah. And it all of a sudden all fits together, doesn't it? Because we've got a GLM. Yes, I'm going to use GLM. We'll have a vec3. And we'll have and vector. Like that. So that's how we do a vector. How do we do a Boolean? Let's do, obviously, an int location. Just makes the programming so easy doing it this way. And here we'll have a bool and value. True or false. Okay, we're happy there. Matrix, I bet it's the location that we need. It's a joke, isn't it? I mean, programming is this easy. It's just knowing that you need to do it. That's the secret to this, is having a blueprint on how you want to do things. So I've made my blueprint, which is foundation base shader. That's what we're writing now, which creates the shader. And then we're going to do a color and a texture shader next, which will inherit all of this lot. Load a matrix. Where are we getting a matrix from? We'll have that from GLM as well. We'll have a map4. I'm going to put a 4 on that. I'm going to put, for now, a 3 on that, because I am not sure how I'm going to do these yet. I know it's stupid, isn't it? And that's just a matrix. There's no and on a matrix. Don't use and on a matrix. You'll find out why. Okay, if Aurorazar, I think that's how you pronounce it. Do you think the idea to generalize shader functionality is an effective one? I mean, why you don't just do a shader class with constructor, yeah, on use and destructor, yeah, and fill in the layouts, views and passing data to shader in separate draw calls of different objects. Now, the reason for that is, one, I'm doing batch renderer, and the second reason is, in other words, one shader will be used and then discarded, and then the next shader gets used and discarded, but they only get used once per draw sequence. The second thing is, I want constant uniformity between all of my shaders so that I can expand the shaders easily. Now, I'm only going to be writing 2 shaders because that's all I've got at the moment. But what happens when I want to add the terrain? I'm going to need a terrain shader. How am I going to add it? With a system where you just do one shader class, you would have to do one shader class that is going to become very, very large. This one that I'm writing now is a base class to be inherited multiple times. It will be inherited once per shader, and each shader will have its own class. And this is the trick to the system. Expanding the system then becomes very easy, because when you see me write the shader, it's going to be stupidly easy, because this functionality here is already pre-written for us, and that's the whole point to it. But yes, you're quite right to ask. Absolutely 100%. And again, it allows your optimization to happen. because your compiler will see that you're doing this, and it will be able to compile all of the code so that it's close together in assembler for its functionality, and any functionality that's duplicated will only be compiled once. Think about that. You've just made a very small program out of a lot of typing. It's more effective to inherit and do it this way than it is to write out the classes. People don't realise that. They think, oh, but you're doing a load of classes. No, you're not. You're doing one class, but it's effectively duplicated, and the compiler knows that. The compiler will compile it all into one thing. Beauty, isn't it, eh? Beautiful. It just makes C++ so powerful. It's quite amazing. No, don't call yourself an amateur, never. Just call yourself an explorer. Yep, straight things robustly means you're an explorer. There's no such thing as an amateur in this game. You're an explorer. I'm an explorer. That's my job. My job is to explore C++. I am R&D. That's my job here at Amber Skies. I do all research and development. So this is you're seeing me do my research and development, and everything that I research and develop, by the way, is given to you free. I asked for nothing in return. But at the moment, the bugger's not giving me any project funds for a Mac. We'll see about that. I want to get one this year before Christmas, because I want to try this out. I've got a double A here. Shouldn't it be a double T? I think it should. Yeah, that's better. That always confuses me because I put these two in as attributes and attribute. Ask more, yay! That's the way to say it, good 'un. I've given you the all. Oh god. Yeah. TD. Oh god, how am I going to program this now? I don't know. Well, what should we program first? Load float. Let's do load float first, because that's easy. Oh, bless. Oh, god, Twitch beg. There's such thing as Twitch beggars, is there? I've found the bots. The bots are funny. Actually, that reminds me. I'm not monitoring my stream, am I? In case we get botted. I got one yesterday and I couldn't delete him because I wasn't watching the stream. Let me just pop a watch on the stream. There it goes. There we go. Stream's under watch now. No, it's not. It's the wrong page. Dashboard. Thank you. Thank you for that. Thank you for reminding me. If bots come anywhere near me, I'll just delete them now. So, functionality. You're going to laugh at these functions. Guess how you load a float? You do a GL uniform, because that's what these are for, uniforms. Uniform, and it's a float, so I'm going to do 1F. One float. Uniform 1F. Open that, and it asks for the location. Okay, let's type in the location, see what happens. And then it asks for a value. So let's type in value and see what happens. Does it like it? Yeah, of course it does. That's it, we're done. Next. Yeah, it's silly, I know. How do we do a vector 3? You're going to laugh at this one, it's funnier. We are going to use GL uniform. Did I say 3? Yes, uniform. And it's going to be 3F. Come on, uniform 3F. Come here, you little bugger. 3FV, no, 3F. There it is. Yeah, I know, it's completely. Auto mod. held a message for a reason. Why? Allow. Stop it, auto mod. Allow this person to say. This uniform function. Yeah, templating. No, it's one that I've written. Oh, I wrote the initial one last year. November of last year. You'll find it on my YouTube. It's the very first thing I ever wrote on YouTube. YouTube, you'll find Amber Skies. So Amber Skies, just look it up on the C++. By the way, all the stuff here is free. Go to your playlists. Make sure it says created playlists here, or click on it to say created playlists, and you'll find it in this stage 1, 2, 3, 4 testing game program series here. The very first one I ever did. So you'll find it in there. I did exactly the same there, but this one's being modified. Alright. So it grabbed a message again. Oh, I don't care. Oh dear. I think we're mature enough here to understand what function means. Even though you typed it in a nice way. Let's give it the location before I laugh myself to death. And let's give it... what did we actually put under here? And vector. Oh, that's lovely. We can just use a vector then, can't we? We can use vector dot something or other. Do we need to? Can I use dot x? No. No, I can't. Whatever I put there, I can't use. X. Yeah, I can use x. Comma. Oh, lovely. Vector dot y, comma, vector dot z. I can semicolon that off, and there you go. That's how you put a vector as a uniform into your... do we need anything more than 3? Did we do any 4 vectors? Where's my shaders? Oh, we did. Map 4. Oh no, it's a vec3 uniform. That's okay then. Vec3. That's okay then. Vec3. That's okay then. Vec3. That's okay then. Yeah, don't need anything more than vec3. We have it beaten. Yeah, it allows .x and .rgb, yeah. It just wasn't coming up straight away, that's why I was wondering. I mean, IntelliSense on this is Microsoft, so you have to give it a while to think. Like it still says that isn't think. Yeah, right. So as you can see, these are suddenly becoming very, very easy. This is an int. But we have to turn it into a float. So float. Float. Result. Result equals. Why do we have to turn it into a float? You're all asking. Because there isn't a GL uniform for an integer. I think there isn't. One might have been added since I last did them. So don't worry. You might be able to integerize that. If value is equal to nothing, true, then result equals 1. Result equals 1.0f. That's how you get your true value. And then, well, it's GL uniform. Yeah, you guessed it. This is so funny. No, I've got my caps lock on. It's not working. Uniform. And it's 1F. 1F. Again. Location. Comma. And result, maybe. There you go. That's how you do a Boolean. Very simple. Make a, what's it called, OpenGL structure to pass instead of separate values that stores all views, light, info, and so on. Probably, yeah. No, you're exploring, you're doing good. Yeah, you're quite right. Is it better to pass a structure? Yeah. And you're going to probably find we are going to be making some structure somewhere along the way to help us out. At the moment, we don't have a camera or lighting. I haven't done those yet. So we haven't inserted that. And I'm thinking that you're right there. And that's possibly one of the avenues we'll go down. So that's one of the things with this being like a prototype. We can do anything we want and we can experiment all we want. I've even labelled it Prototype 1 at the top. So yeah, on the main program that we've got, which actually has the Windows, the server and the display, we're actually on Prototype 2. So we're actually past this stage. We've actually got proper functionality in that. So this all has to go through a second stage yet of not integration, but how can you put it? Me optimizing it, me breaking it down a little bit, possibly redoing it in bits to make it, you know, proper functionality and stuff. So I will be going through it. I'm not sure what rules I'm going to use to make Prototype 2 yet. Global uniforms, totally. Yes, use them, please. Everybody, you find an expert, they'll shout at you for that. You find an explorer, and an explorer will say, yes, use it. You'll never find every single game that's ever been written out there on the market right now has a global uniform in it. I bet ya. Every single C++ program at some point has global variables of some type. I have a global. I have a global model structure. It's hidden in... Ooh, it'll be hidden. I'll show you. It is actually a global. Is it in the header? Yeah, there you go. Struct model. It's not in a class. So our model is global in Amber 3D namespace. So yeah, there you go. There's your model struct. So you're quite right to use that kind of thing. That's exactly what I've done for the model. Will I be doing it for the shaders? Probably. Somewhere along the way. You never know. Let's get this matrix up. Oh, this one's fun. Let's use GL, not a Z, and whatever that was, uniform. And we'll have matrix. And we'll have 4x4 matrix, floats, and I can't remember, but I think we just stick a V on the end. Yeah, we'll do that. There we go. It's happy now. So we'll give it a location. I think this is the weird one. Is this the weird one? Yes, it is. What does it want now? Size. Count 1. Yeah, that's easy. What does it want now? Transpose. GLM is in OpenGL format, isn't it? Yep, so that's going to be GL false. If it's my maths library that I've written, you put GL true here. If you're using GLM and their library, you put false. Because I always write my library the other way up. That's all. And now we just need a const GL float star value. Anybody know the answer to that one? Does anybody know what that looks like for a matrix map 4? It's ridiculous. What it's asking for there is the address of the very, very, very first number or location inside the matrix. At which point, Keanu Reeves will pop out and kick the heck out of your code. Oh, so he says. Matrix. Dot. It isn't. I bet it's that one. I bet it is. Yep. That's the address of the first number in the matrix. And that's how you write it. You write it as you say it. Say as you see it. Global shady uniform. Ooh, now we're talking. That sounds sexy. To a computer programmer, that sounds sexy. Lovely. That's right, yeah. That's roughly how I've written it. What I've written will work. Yeah, that'll do those. Have we got anything down here that needs writing? Not that one. Not that one. I don't think so anyway. I'll check it though. What have we got here? Alright, okay. So I'm going to put a note in here. No, not in here. I'm going to put a note in here, which just says override this to set the attributes list. That'll become more obvious when we get to it. Nothing in private. Oh, I've only got one left to do. This is it. This is the last part. This is nice. I like this one. This is a nice class. Nice and easy to do. Oh, God. What have I got here? This is bind attribute singular. So this will be GL bind attribute location. Yeah, that was it. To remember it. GL bind at it's the top one. Attribute location. It's going to need the program. I think we've got that. As program ID. Index is the attribute number. So we don't need M program ID, do we? Yes, we do. Yeah, attribute number. So that's attribute. Yeah, that'll work. What we've got next? Const GL char name, which is variable name. And that'll work there. Nice one. Yeah, all done. Dusted. Fine. That's lovely. Still worried about that. So let's just check that I have done everything correct in the shaders. The core shaders. Uint shader program. Don't really need the one on the end anymore. Come off it. That's correct. Make sure I stripped off the vertex. Yep, I have done. Excellent. So that's okay. Don't need anything else. That should do it. Yeah, they will die on that. Yep, that's okay. Yep. I'm happy. They're not global in any kind or member variables or anything. They'll die nicely. Lovely. Everything's hunky-dory. What I'm just going to do is that, because we don't need it anymore. And we'll start our next class, which is going to be Oh, we'll call it color shader, shall we? Texture shader to color shader. I might do the texture shader first. I'll try doing the color shader and see what happens. Color. I don't know what's going to happen. Shader. So we'll do that. We'll open that up. We'll do semicolon. Public. Do I need protected? I think I do. So I'll have protected. Yeah, just in case I need it. And I'll have private just in case I need it. Alright, I doubt it. But we never know, do we? So here, under public, we have color shader. And then it's just something strange goes on. So it's just going to be colon, public. This is inheritance for you. Public, and that's going to be shader foundation. So we're including all of shader foundation in here. Lovely. It doesn't like it. It's in the same namespace, so it should be able to do it. It's only there. Yeah, that's right. Alright, okay. Get rid of you. No, I'm doing this the wrong way around, aren't I? That's bad. That's bad of me. I'm doing it the wrong way around. You see? It's even catching me out. Let's pop it on there. So, color shader itself just needs the shader name. Again, should I make it explicit? Not as bothered here. So that's going to be const std colon string, and that's going to be, and at this point it's just going to be a shader name. And all you do is you literally put in the shader name. Do we need anything else on this? Nope. Don't think so. We'll see. We'll see. I'm not sure about that one. So now we just need a title. Color shader. No, we don't. Can't do that. It's an override. Yes, we can. Don't put anything in it, and we just put an override on it. That's better. That'll work. Oh, don't do that to me, computer. I hate that. Right, so I've got those. What else do we have to include? We have to include everything that's been done before us. Right, so the one I set to override was unprotected, wasn't it? Yeah, that's good news. So we're going to use that, definitely, as an override. Ah, that didn't work very well. That one, there, thank you. No default. No default, but so why are you complaining because I put that in? Dar. This is where that explicit will catch me. No, it's going to be asking me to do one. Darn it. Oh, that's a shame. That is a shame. Darn it. I wanted that as well. God darn it. C++, you let me down. Oh, bless. Don't know what it's going on about now. Yeah, right, okay. I'll let it complain to itself. Yeah. Parent constructor needs to be called, yeah. Nothing we're going to worry about. It'll fix itself, don't worry. That protected one is very important. We're going to put it here. This is void, and its bind attributes. It's got to be the right one, so it's the plural one. The one I want to override. And that's my override. There. And, oh god. There we go. We'll do that in a bit. What else do we need? We need all those loaders, don't we? So we're going to need void. We're going to need all our loaders now. So it was... Oh, it doesn't matter. Shall we put them in the same order? We'll put them in the same order. You lot. Come here. Don't need the last one. Never do this. Please note, people at home. Never do that at home, as it may endanger your program to crashing. I'll just highlight that. Via. Get rid of you. Get rid of you. Get rid of you. Get rid of you. And get rid of you, because we don't need that bit. Get rid of you. Get rid of you. Get rid of you. Okay, that looks better. Let's do this one. I don't know, which one should we do now? And I need a stupid one, don't I? One I hate. This is one I don't like, because this is where I think C++ lets us all down. I know it's already trying to now. Get all uniform. So it's get all. No, I'll put it in lowercase. All uniform locations. That's a nice sentence. No, I'll leave it open now. I don't like that one. Right, it's still got problems with me. Actually, is it still having problems down at the bottom as well? Yeah, it's still having problems with that thing down there. Just let me close. 1,000, 2,000, 3,000, 4,000, 5,000. Open. Microsoft, can you please get a catch-up and on the ball type of thing? Nope, it is an error. That's okay. Oh, it's because of that. Yeah, that's fully built. You should be able to tell from there. Oh, of course, IntelliSense can't, because it's not programmed to do so. That's lovely, IntelliSense. Really good programming. Yeah, parent constructor needs to be called. It really doesn't. It really doesn't. It'll do it for us. It's just that code, this version of Microsoft Code, possibly doesn't understand that. Which is fine. Our compiler does. Our compiler will be happy with it. That's what matters. Let's see if we can change it anyway and see if we can get something rolling here. Right. Let's put something else on here then. So it's got, yeah, this will fix it. Let's pop this on here and let's do what it's telling us to do. So it's shader foundation, isn't it? Shader foundation, and we'll just pop the shader name in there, like that. That'll do it. I've got and shader name with a low S. Yeah, that'll do it. That's what the error was. Yeah, you're quite right. Yeah, we've done it. I'm going to do an SDL underscore log. I'm trying to do this with all my constructors so that I can prove that the thing's working, and I can show you on screen that it's working. So all my constructors are getting logs. So color, I can separate it off here, shader, constructed. That's all the constructor is going to do. Yeah. And override here. Yeah, we've got an override, so this will now be able to destroy. I'll put it as empty for now. And I'll put my SDL. In the final version, you take all these SDL logs out. Trust me. Well, possibly not, because they're useful, even in the final version. Color. Shader. I'm going to use shutdowns for these, because it sounds better. Or destroyed, whatever you want to call it. Pop you in there. Okay. Looking good, looking good, looking good. Load of float. What the heck I'm going to put in here? Ah, dear. Oh, there's tons of stuff I've missed. Alright. I need to know what I'm doing with my light as well. I'm going to have to put my light in amongst this lot. Yeah, I am. Void. Load. Yeah, light. That's going to have to go in here. That's going to be... We'll call it an entity of some kind, or model. No, it's not a model. An entity, a thing. We just won't call it anything at the moment. I'm just going to call it X. Because I don't know what to call it. There you go. That solves that problem. Oh, wait a minute, no use. Needs a value. Right, so we've got light, comma. I'll change that as a need to in a minute. No, we'll just put int. Why not do it properly? And we'll just put light here. Now it exists, so we're alright. It's not going to throw a wobbler. Right, first thing I'm going to do is load the model matrix. Let's do that first. Let's go down here and load a model matrix, and I'll worry about that in the back of my mind. To load a model matrix, we're just going to literally call load matrix 4. We're going to open that, and we're going to need a variable. And we're going to call it m_model mat lock or location. We'll figure that out in a minute. And then we'll just have a matrix. There we go. That's it. M_model mat location. That's going to be a int. it's just an int. We can pop you in here. Should I set its value? Location is used. Think about that in a bit. Not sure how I'm going to approach that bit. So model mat lock now exists, but it doesn't have a value. That's a problem. I'll give it a value for now. And it's throwing a wobbler still. It's throwing a wobbler because it's calling itself. So I've done something silly. Ah. If I put model there, it'll work, won't it? Yeah, it's my namings. My namings are now conflicting with whatever we've got in Shader Foundation, so I've got to be careful about my namings now. That one has to conflict because it's an override. Load boolean, that's a confliction, isn't it? No, not to worry. Let's load the view matrix. So we're going to need another one of these, but instead of model matrix, let's load the view matrix. Yeah, let's do that. Copy you. This isn't hard. So now we change model to view, MVP, if you remember right. So that's our view matrix. We'll pop that through there, and that just stays the same. But we need to change this, really, don't we? This will be mView mat lock. Yeah. I can see it's getting quite a few of these. View mat lock location equals, I'll stick it at -1 again. -1 can't exist, by the way. It's illegal. But they're int, so I don't mind. Copy. Paste. Now if we've got model and view going through, we might be able to do projection next. Yeah, let's do projection next. MVP. Let's get them all in the same place. There we go. So that now becomes projection. That's going to be a bit of a wild one. So load projection matrix, and then this just changes here, doesn't it? I think we'll go and write it out first. Oh dear. Int and that's projection mat lock. You can see why I abbreviated the other bits now, can't you? Yeah. Copy. We'll pop you in there, and job's a good 'un. Magic. So we can take the matrix is in. Yeah, that's our MVP done. What else do we need? Light. Let's do the light then. How does the light get in there? It gets in there as possibly, we might have to call it an entity. Yuck. I hate that word. I've really gone off it so badly. Entities usually mean you're going to be using an entity component system. And when you start using an entity component system, you may as well just go down the library and start reading a whole library. It'll take you about as long to read the whole library than it will to write the entity component system. And you'll have learned a lot more by reading the library than you will have done from writing a component system. So that's my advice. Go down to the library and read all the books there. Don't ask me if I'm going to be using a component system. Part of it is, there might be bits of a component system in there, but only the bits that matter. The rest of it's just for jollies. Somebody wanted a job one day and said, oh, I know how to do entity component systems. I've got a job. Yes, and I can make it all good for you. And they got a job. Oh dear. How bad. Yeah, I don't really know what to call this light. Right, we're going to need to know two things about our light. And those are things, that's your MVP done. Right, int. We're going to need to know light, m_light. We'll need to know its position. Location. I think we do. We're doing colour shader, aren't we? Better check, you know. Where did I put my shaders? Colour. Vert. Yeah, light position, location. So that's that one. And if you look in the fragment, light colour. So we need those two. And that's not, yeah, that's an int. Just about to say, that's not an int, yes it is. And we need int m_light color lock equals -1. So light position and light lock. So what do we want to do with our light position? Want to do something with it. It's a vector, or it will be. So we'll put load vector, which we've already written. There you go, vector 3, in fact. Yeah, that's correct. And all we need to know is position and sorry, location and position. Yeah, okay, got you. Light position location, and we need an lpos. We haven't got that yet. And for the other one, we're going to do load vector. It'll become clear in a second or so. Don't worry, I'm just having to put this together like a jigsaw puzzle. m_light color, and that's going to be lcol. Right. So we need two variables. Retio. So vec3 is going to come from GLM. So get ourselves a vec3 called lpos, and that equals light dot whatever. Get position. I don't know. It's going to equal something like that. So light is a struct. Great. So it's not an int anymore. It's a struct. Light. There we go. We'll just do that, 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 that. And it's going to have get position. For this to work. And that's just going to be return -1. Because we can. That's okay. We've got no constructor or anything. I don't think this is going to be right, but it might be. And what we're going to do now is get light color. Yeah, okay. Get light color. Two of those thingies. One of them. And a return of -1. Semicolon. Light. Semicolon. No ideas why I'm not allowed to do that, but anyway. Don't really care. Just gives me the ideas of what I need anyway, so that's perfectly alright there. So you've got your light position. And what we'll do is a glmvec3 again for the colour. So glm, or what we're going to be doing basically is pulling the colour and position out of our light entity, we'll call it. I'll just call it light, I think. Just skip the entity bit. There we go. Equals light. And that would be dot. And it would be get light colour, whatever we put in there. Right, okay. Right, so that's what light's going to look like when we decide to make it. It's going to look something like that, I think. I think that's a good structure for it, but that struct is not going to be there. It's going to be somewhere else. We'll probably hold that or pass it in. How do we pass in the light? Interesting question. Oh no, it passes the light in there. So this structure will be held somewhere else and it'll just be passed in here. And it'll do all of this for us. All the squigglies, which is good. That's the way it'll work. It will work, don't worry. So we are going to need a structure for light. Okay. We'll probably put it where the model is. Structure for the model. Okay, cheers. Oraxar. I'm going to pronounce it as for now. You take care, mate, and have fun. That's the biggest bit. Always keep exploring and always keep having fun. I'm having fun trying to build as much useless code as I can here. That's useless. There you go. Oh dear. Take care, mate. Floats. What shall I do next? I will load some floats up. Oh, I remember what these were. I've been messing about with shine dampening and reflectivity for the lighting. Now, I think I want it in here because I put the variables into our shaders so that we can use them. So I think that's what we'll do. Load shine variables. Yeah, I'll do. They're very, very good. When used properly, that is. Variables. We'll need a couple of floats for that. So we'll just take them as damper and reflectivity. My favourite word in the whole of this is reflectivity. Because I'm going to misspell it galore. Right, so what we're going to do with these, it's just going to be a straight load float. Yeah. And it's just going to be M underscore damper lock, comma, whatever, damper. Like that. And the next one is going to be load float, and it will be M underscore reflectivity lock. That's a nice one. Comma reflectivity. I'm doing it on purpose. Anybody who can type that in without getting it wrong deserves a prize. So I'll have a damper lock, please. This list is getting nice and long. Oh, well, it's part of the light, so I'll keep it with light. I'll set that to -1. And we'll have that one. And that's M underscore, just V it. I was going to type it out then, just because I enjoy doing it. Make sure I've spelt it right. Reflectivity, yeah, as in nativity, I suppose. Let's have a look down here. Well, I didn't spell it right then, according to that. No, I put 2 M's at the beginning, didn't I? 'Cause I'm an idiot. There you go. Well done. Fine. Anything else I'm going to need? Get all uniforms. Right. Right, so these are empty. Actually, I'll just take them out. They're just distracting. Okay. Let's go down to this one now. Right. Well, all of those locations that we've decided we want. There's 7 of them. Is that all I've used? Colour shader. 1, 2, 3, 4. Fragments. 5, 6, 7, yeah. That's all I've used. Wow. I've been very, very reserved. We'll have the lot, because that's what we need in here. And all I need to do is put a line there. And Shift-Alt there. That'll get rid of that space. Now I need to do it again, because we've now got a flasher in the wrong place. So there, Shift-Alt to there. 1, 2, 3. That's it. Right, all I want to do is put something where it says -1. So that's going to be GL get uniform. Yes. Location. Oh god, is it not up on the screen? Yes it is. That one there. It gets silly, doesn't it? And that will be get. We need, what do we need? No, sorry, I don't think I caught. Right, yeah, we need the program. Well, that's easy. That's get program ID. There it is. Thank you. Next, what do you want? GL char star name. This is where we've got to be careful. Luckily, I use the letter U for all of my uniforms, so I know it starts like that, and then it'll probably just be model. But you have to have the exact name. So it's U underscore model. That's the location that it will get, and it will return it as an integer. And so that will then mean that we can place values into uModel. So UV projection, yeah, light position. There's nothing strange going on in that one. So it's again GL get a uniform location, that one. I'll trade you -1s for that. Because it's what I want. Okay. Actually, I can trade as much as up to there, can't I, really? Because they're all the same. There we go. Build it up. And all we have to do now is put in the name. So it's going to be hey you underscore view. Close inverted commas. Close brackets. That's okay now. This one's going to be you underscore. Oh, did I put proj? There we go. No, I put projection. Wow. Projection. How's that for being posh? Eh? Posh word there. This one is U underscore light position. And I think I called it light position. I think I did. Again, always check. Yep, we're right so far. So we're now on to the fragment shader. So it's still U underscore. And we want light color. There we go. Check that in a mo. And here we want U underscore. Just damper. By the looks of it. And here, oh yes, we know what this one is. And that's going to be reflectivity. That should do, actually. Stop you there. Okay, so light color damper and reflectivity. Light color shine damper and reflectivity. So shin. So I'll just pop that there, and everything is correct. Lovely. So that'll fill up that part of the uniforms. So we get all the locations, and then this is able to load them up. That's nice. Lovely. I'm just trying to remember where to use the guess all uniform locations. There is a place to use it, and I will have to work that out. But hey ho, what we don't want to do with bind attributes. Doesn't bind attributes just switch them on? Yeah, that's what I thought bind attribute did. So here we have to bind them all. These attributes are going to be in the vert shader here. It's going to be 0, 1, 2, position, normals, colour. Ah, pluralised it. Damn. Yes, of course it did, yeah. Position, normals, colour. Okay. So the binds have to follow that. So it's bind attribute. That's got the OpenGL call in it somewhere. 0, comma. And that is going to be lowercase positions. Position. Okay. Again, bind attribute. And that's going to be 0, comma. What was the second one? God, I've forgotten already. God, I'm bad at this, aren't I? Position, normals, colour. I bet you never realised how much you could put in to make it so easy to do. Bind attribute, singular. And that's just going to be 2. Comma. Didn't do that right, did I? And that's going to be colour.